There we go. Now we're recording. Okie dokie. So at the request of a student, I am doing a quick little video on writing the equation for rational expressions. This is just working backwards. So we know that our denominator, so whatever's left in the denominator, gives us vertical asymptotes. And we know that anything that canceled from both the numerator and the denominator gives us points of discontinuity. So those two pieces of information are what you are going to use to figure out what this equation was. So I have a vertical asymptote in this example at x equals -2. So that means I have an x plus 2 that's going to be left on the bottom. Otherwise, if it wasn't left on the bottom, if it had canceled, I wouldn't have a vertical asymptote there, right? So because I have a vertical asymptote at x equals -2, it means I have an x plus 2 in the denominator that will be left over in my final answer. And we look at our point of discontinuity. So my point of discontinuity occurs at where x is 0. So that means I had a single x that was on top and on the bottom. Those two things would have canceled. And because they canceled, I know that I'm going to be left with something over x plus 2. To figure out what that other bracket might be, we just use points on our graph. So I can use the point of discontinuity. So the point of discontinuity is at 0, 3. So that would be when we have an x value of 0 and a y value of 3. I can use this x-intercept here, -6, 0. Either of those will work. I just need a nice point. I could come over here to 2, 2. I could take that one as well. I just need some nice whole numbers. And that will be enough information, having an x and a y, to figure out what that bracket on top must be. So I'm going to go with 0, 3. And basically what you do, you plug it into what you know. And what we know is that I have to have an x plus 2 on the bottom. So if I plug 0 in for x, I'm going to have, well, 3 equals, sorry, not y equals. We know what y is. I know that 3 is going to equal 0 plus 2 in the denominator. So 0 plus 2 in the denominator means that my denominator will be 2. So now just work backwards. What is my numerator going to have to be so that when I divide it by 2, I will get a y value of 3? 6, right? My numerator must be 6. So then again, we can work backwards. I know that x has to be 0. So what can I add or subtract with 0 to make it 6? Well, I know I have 0. I want it to be 6. So I'm going to add 6 so that I can get 6. So again, working backwards, I know that x is 0. I know I want to add 6 to it so that it can be 6. So it means my top bracket, because 0 was replacing x, my top bracket must be x plus 6. And then you can double check if you really want. 0 plus 6 is 6, 0 plus 2 is 2, 6 divided by 2 is 3, so 0, 3. If you want to double check with the x-intercept, we'd make y 0, cross multiply, the x plus 2 would disappear, you'd get 0 equals x plus 6, bring your 6 to the other side, and you get x equals -6. Okay, and it's not a bad idea to double check because sometimes maybe there could be a coefficient or something that we're missing. So you do want to double check with another point, but most of the time that's it. It's just working backwards to figure out like what canceled, what must still be in the denominator, and then what does my numerator have to be so that I can make any of those other y values that are on the graph. Okay, so just looking at the next one really quickly, we have a vertical asymptote at x equals 1, oops, which means I know I'm going to have an x minus 1 for my denominator. Then I'm going to look at what would have canceled from the top and the bottom, and you can do that in any order. You can look at what would have canceled first. So at x equals -3, I have a hole in the graph. So x equals -3 must have been an x plus 3 that canceled from the top and the bottom. Then this time I don't want to use my point of discontinuity because it's not really on a nice number and I'd have to guess. Like that's 3 comma, I'm guessing 2.5, but hard to say, right? So I'm going to pick a nice whole number. So I'll pick -7 comma 0. -7 comma 0. And then there's a couple ways you can think about that. To be honest, taking the x-intercept, I'm just realizing this now, makes it a little easier to figure out what that numerator would be. Because, I'll even go back to the last example, x plus 6, I know I had a x-intercept at -6. I know that for my x-intercept, I'm really only going to be looking at that numerator. So it would basically be, okay, well, I'm going to bring it to the other side because y is going to be 0. So this would have to be x plus 6 because the second I bring it to the other side, that would give me that x-intercept of -6. So with that in mind, if my x-intercept is at +7, I bet my top bracket is going to be x minus 7 because x minus 7 would give me a positive x-intercept of 7. But let's take a look and we'll kind of work backwards like we did last time. So I know that the x plus 3's will cancel from the top and the bottom, which means I'll be left with just x minus 1. I don't know what my numerator is, but I know that when x is -7, why is that -7? When x is +7, sorry, I think I was thinking ahead. When x is +7, I should get a y value of 0. So let's just start with the bottom. 7 minus 1 is 6. So what divided by 6 would give me a y value of 0? Well, 0 divided by 6 would give me a y value of 0. So I know that x is 7. So what do I have to do to 7 to make it 0? Well, I have to take away 7. So my top bracket must have been x minus 7. And then again, you can just double check that it actually works. So 7 minus 7 is 0. 7 minus 1 is 6. 0 divided by 6 is 0. And you could pick another point too if you want to really be certain. So I kind of want to go with positive numbers. I'm out of luck. Okay, let's say we picked -1, comma 4. When x is -1, y should be 4. So -1 minus 7 is -8. -1 minus 1 is -2. And -8 divided by -2 is 4. So my simplified expression would have been x minus 7 over x minus 1, which means my original equation, when I take into account what would have canceled, is x plus 3 bracket x minus 7 over x minus 1, x plus 3. That's it. If you really want to take it a step further, you could FOIL those out and write them in standard form on the top and the bottom, but factored form is fine. Okay, so it's really just working backwards. Don't overcomplicate it, all right? Your vertical asymptote is going to be the binomial expression that's left on the bottom. Your whole is going to be whatever canceled from the top and the bottom, and then you just pick points to figure out x and y. All right? That's it.